This video is looking at how we do some linear modeling. So that's when you have a real life situation and you want to actually model that out with an equation in a straight line. So in this case, we have Dario has borrowed $200 from his parents and he's agreed to repay them at a rate of $40 a week. We want to write an equation linking the amount that he owes with the number of weeks that have passed. So obviously one of these is going to be our x and one is going to be our y. As you probably saw in the summary sheet, by convention, because it doesn't matter really which way around you do it, but by convention, any time period is going to be our x value and the other variable will be our y value. So in this case, we're going to say our general form would be a equals the gradient times n plus the y-intercept. Now we need to work out what m and c are in this case. So our starting point, he borrowed $200, which means that that is the first thing on our graph. When there's no time has passed, he's borrowed $200. So that is going to be our c value. So we've got here the amount equals something times the number of weeks plus $200. Now we know that his balance owing is decreasing by $40 a week. So here, because we know it's decreasing, we know it's going to be a negative, and that's going to be our gradient. So we can think of this, that the amount he owes is equal to the number of weeks times the amount he's decreasing by, so that's why it's a negative, plus the amount he owed initially. Your textbook might write this out as a equals 200 minus 40n if it was doing this problem, just because that sort of matches up, that it's the amount is $200 minus the amount he's repaying times the number of weeks. But just to keep it in the same form, we're going to have it written this way. So our next part is we want to know after 3 weeks, how much does he still owe? So in this case, n, our number of weeks, is going to be 3, and we substitute that into our formula. So we have a equals negative 40 times 3 weeks plus 200. Now we know negative 40 times 3 is going to be negative 120 plus 200. So we can think of this as just 200 minus 120. So the amount he still owes comes out to $80. Part C, we want to know what amount is owed when n is equal to 0. Well, we know because n is the number of weeks, when that's equal to 0, then obviously we're thinking about this as n and this is a. When n equals 0, it was the amount that we started with. So we know that when n equals 0, the amount we started with was 200. So a would equal 200. We also want to know how many weeks will it take him to repay his whole debt. So remember that our equation here was the amount equals negative 40 times the number of weeks plus 200. So we want a to be 0 because we want his amount owing to be 0. So we substitute that in, that 0 is going to equal negative 40 times n plus 200. We can rearrange that to say 40n equals 200. Therefore, n equals 200 divided by 40, which is equal to 5. So, therefore, it will take him 5 weeks to repay. And finally, we want to sketch this relationship. So the first thing we would do is grab out a set of axes we go. We're going to label these. So remember that n is our x-axis, so that's going to be there, and a is our y-axis. Now, let's call this, or it's just going to be a rough sketch, so we'll call that 50, 100, 150, 200. So we know that when n was 0, a was 200. Now, we also know that when a was 0, n was 5. So we can call this 1, 2, 3, 4, 5. So we know that that is going to be another point on our graph. And I mean, we could go back up here and say after 3 weeks that we knew he'd owed $80, but that's a little bit harder to graph. When we know our two intercepts, that's super easy. And so then we join up our line and we just go shoop. There is our line. And we would label this that A equals negative 40n plus 200. You could label your points as well if you want as 0, 200, and 5, 0. And there you go. You have sketched the relationship. So that's how we work with linear modeling of a real life situation like someone borrowing and repaying money at a flat rate.